My name's Nick. I started Nick's TV Repair about a decade ago, and since then we've fixed over 26,000 devices. Today I'm going to be showing you how to fix a Samsung Frame TV. When I power it on, I do get a faint click from the One Connect box, but nothing appears on screen. The TV won't turn on. Now this One Connect box actually belongs to a 75-inch version of this TV with model number QN75LS03BAFXZA. We're just using the 55-inch for our testing purposes. Now most commonly, a completely dead, no power, or you're just hearing a single click from the One Connect box will indicate that the box itself is defective and needs to be repaired. So let's open it up and find out why. I've brought the box over to our workbench for the disassembly and repair. And if we flip the box over, we're gonna go ahead and identify we have a few screws. We'll go ahead and remove those. And now for further disassembly, I'm going to be using this metal pry tool, and I'm going to sneak it in here between the cover and the bottom plate, and then going to use that to pry the bottom part up, and we're going to work our way around. I think I got it all. We'll flip it over and just wiggle it off the top. And there we go. Now we have exposed our circuit boards. I'm going to go ahead and disconnect our power connector here. We have two final screws to remove the power supply. And here we are. Now this bottom plate has the main board in it. We don't really need that right now. We'll move it over to the side. And I do want to give you a word of warning. We have two very large capacitors underneath this heatsink. They carry a lot of power. So be very careful where you're putting your hands. I usually like to handle the board by touching the sides so that I don't accidentally shock myself by touching some of the pins. And because I had the unit on just a few moments ago, I'm going to use my discharging tool to discharge the capacitors. Yep, and you see that red light? That means there was still some power. Now moving to some multimeter checks, I'm going to put my multimeter in continuity mode. So when I have a short, I get a beep. We have some fuses we'll want to check first. We get a beep, so that's a shorted fuse, that's good. This one also has continuity, that's also good. And this one does not seem to have any continuity. Let me go over to the resistance setting, and it says OL. So this fuse over here is blown. Let's go back to our continuity mode, and let's flip the board over actually. What we're going to do is check some of the transistors on the heat sinks. So essentially, when it comes to power supplies, usually the transistors that will fail are the ones on the large heat sinks. So those are the ones that we're going to be checking out. And we're just going to be doing a quick check for a beep. I'm not getting a beep, so no short, no short, no short, nope, and no. So this whole heat sink of transistors seems good. Let's check out this one over here next. All right, so I have a beep. That means that transistor's reading a short right now. And this one as well. So that's the two that are right here. Let's check these two out next, and then these two. Let's see, no short, no short, no short, no short. And these are actually, I'm realizing, are diodes. And finally, the ones over here on this last heatsink. Let's take a peek. No short, no short, no short, no short. No short, and good. Actually, very minimal damage it looks like. We have just these two large guys need to be replaced. So my first step is we're going to remove them out of circuit, and then we're going to recheck both the boards and the transistors out of circuit. Now these screws are very small, so we're going to have to use a special tool for them. This is a bit of a tedious process, but if we can get this One Connect box going again, it'll be well worth the effort. What I'm going to do next here is try to actually loosen the transistor off of the heatsink, and it is really stuck on there. I cannot remove it. All right, we might have to desolder one or two of the pins first. So just to give you a little bit of a reference point, this is the end of the board. We have our white mark here, and then over here and here are the two transistors we're going to be replacing. And as you can tell, they are covered in silicone. So we're going to have to remove that in order for us to be able to properly solder and desolder the joints. So this can get a little bit messy. Now I'm going to do this off screen, but I'm going to give it a little additional brush over the trash can. And that's just because I am making a bit of a mess with all this silicone on the desk. I'll show you the final result here in just a second. But it is important to get very clean joints, otherwise your iron tip will absolutely not transfer heat properly into the joints, and you might actually risk damaging the board or damaging the traces, the pad. So here's our final product. I'm gonna go ahead and start adding some fresh solder actually before we desolder. I typically add new solder to the joint just to make sure I can get good flow. If the old solder previously on the board is oxidated a little bit, it does make it a lot harder to get good flow, so this will help me burn off that layer of oxidation, get good contact and heat transfer between the iron, the component, and the joint. And I can tell I'm having a hard time getting good flow, and that is partially going to be due to the fact that this board is very thick. The pads are very big, so they're going to soak up a lot of the heat, and that's going to make it a little bit harder for me for the soldering and desoldering. I'm starting by the single leg in the middle because I believe that one's going to be just easier to desolder. It looks like I got most of it on this one, but not this one, so let's add actually a little bit more, get good flow. Try again. Better, but not 100%. Let's try attacking the other joints next. See what we can do. Same thing. I got a good chunk of it, but not all of it. There we go. There we go. That was a good one. Kind of loose. I can feel... Okay, yeah, it is loose. But I can feel a lot of resistance on this one. Let me see if I can get the rest of the solder with the wick here. And if not, we'll try the desolder pump again. Nope, still have a little bit of solder here in that corner. We have a loose leg. I just moved the pin over as I was desoldering it. There we go. Okay, now it's loose. All right, 2 more joints. This one's definitely giving me a hard time. We're gonna add a little bit more solder. Try and get good flow. Wow, I'm really having a hard time here. The problem I'm seeing here is I can visually tell there's a little bit of solder still stuck inside that joint, but it's definitely below. It's like almost on the other side of the joint, so I'm having a hard time getting to it. But I think our pin is loose enough, and this one's not loose at all. We're almost there. Pin's moving. I think we got it. Let's just check real quick. No, not quite. Okay, with most of the legs desoldered, let's see if we can try and remove the transistors from the top now. I'm putting a lot of force on there and it's not budging at all. Oh, there we go. Finally just got it. All right, that's our first one. There we go, just got the second. So here's what we're gonna do, because the second is still soldered in with that middle leg. I am holding on to the transistor from the bottom, and we're gonna go ahead and try and desolder at the same time as I wiggle it out. There we go. Now I'm definitely gonna wanna give that heatsink a good clean. We're gonna wanna make sure that our replacement transistors have a flat surface to dissipate their heat into. Do we still have a short in circuit? Nope. And nope. And nope. Are the transistors shorted? Yep. Yep. Absolutely, both of them are. Here are the replacements, and of course, they are not shorted. Now, if I just feed them through and solder them in, I'm actually going to blow these immediately along with the fuse again, because I do need to put an insulation pad between the heatsink and the transistor, and I'm not going to reuse these old ones. I fear that these might be a little dried up, a little damaged perhaps, so I'm going to put double-sided thermally conductive tape on these instead. Go ahead and cut to size. Alright, and we do want to allow a hole for the screw, so I am going to be using an X-Acto blade to make a little cutout. All right, there we go, our first one. Last part is we're going to need to bend the pins, the center one at least, forward, just like that, so that it fits properly in the board. All right, let's see. Does this go in? So we're going to want to do this one at a time. Make sure the screw hole lines up. We don't really have too much room for error here. Once the tape hits the heat sink, it's going to stick. And I think we might have gotten it. So to make it a little easier, I'm going to go ahead and cut the pins off now. And I'm just going to solder this one down just to lock it in. So that's our first one. Let's go ahead and do the second. All right, I think I have it more or less where I need it. Try and see if I can get the screw tightened up a little bit with my fingers first. Let's go ahead and cut off the leads. Solder those down. And just so you get to see it, magnet chip MDQ23N50D is the part number of these, and we use double-sided thermally conductive tape. All right, and let's check. That one was good, and this one's the one that's not. 250 volt, 3.15 amps. Before we remove the fuse, I'm going to remove a little bit of the silicone here. And it looks like my fuse, one leg is here and the other one is right over here. So same thing, we'll remove a little bit of that coating, silicone. Same as before, let's add just a little bit of extra solder, get good flow. Do that to both legs. Now usually fuses are not on large ground pads, so they should be, in theory, a little easier to desolder. So I'm actually holding it on the back and I'm just going to pull it out one side at a time, and second side, there we go. It's just easier that way. Our fuse is out. We're going to feed through our replacement. The replacement is a glass fuse. It is, however, still rated for the 3.15 amps, 250 volts, and it is also a slow blow fuse. So even though it might look different, all the properties are the same as the original. We're going to do a final cleanup, spraying the whole area with some 99.99% isopropyl alcohol. All right, we're going to do a final brush and clean over the trash can again. I did notice there was a couple loose pieces that we want to get rid of, one of which was a piece of metal, which we definitely want to get rid of from the desolder pump from earlier. I don't know if you spotted it. This power supply should now be fully functional. I'm going to put it partially back together. We'll test it, and then we'll go ahead and put it fully back together and send it back to the customer once we've confirmed everything's working. Okay, we are plugging the TV back in, applying power. Our one connect box just clicked, and here we are. The TV just turned on, so it looks like we do indeed have a successful repair. If you have a one connect box that you would like to send in for us to fix, we offer flat rate services, which come with a 1-year warranty. Those are available on our website, which I will link in the description down below. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.